Okay, so we're going to review what we've been doing. Okay, this is similar to what we did earlier in the week. Okay, we're going to be finding protons, neutrons, and electrons. Okay, so when we're finding protons, neutrons, and electrons, we could be describing different kinds of isotopes. That means we could be describing different versions of the same element, or atoms of the same element. Okay, so normally atoms of the same element always have the same number of protons. Okay, that never changes for an element. But the number of neutrons can change. So when you have more or less neutrons in an atom, that gives you a different isotope. And the number of electrons can change because atoms can lose or gain electrons. But that doesn't change the element. The only thing that would change the element is changing the number of protons. Okay, so let's try some of these examples. Okay, so just to review before we try this example, do you remember what this X stands for? Element symbol. Okay, what does the Z stand for? Atomic number. And then what does the A stand for? Mass number. Okay, so remember the difference between the atomic mass and the mass number is that the atomic mass, the ones that you see on the periodic table, it's actually an average of all the different isotopes of an element. Since some of them have more neutrons or more or less neutrons, that means they don't all weigh exactly the same. So the average atomic mass that you see on your periodic table is an average of all those masses. Okay, so that's why it's a decimal. Okay, what I showed you earlier was that if you round the average atomic mass to the nearest whole number, it gives you the mass number. Okay, so the mass number is basically the mass of one atom of that element. And all of the mass of an atom comes from the protons and the neutrons. Okay, so the mass number gives you the protons and the neutrons. Okay, so the little p plus means protons and the little n0 means neutrons. Okay, so remember that's why we had to subtract when we wanted to find the neutrons. We had to subtract the atomic number from the mass number, because if you subtract that, you're subtracting the number of protons, and that leaves you the number of neutrons. Okay, so let's answer this problem. We're going to put a carbon, we're going to put this information, we're going to use this information to find the atomic symbol. We're going to find A, Z, and X. Okay, so we know that it's carbon. So is that going to be the A, the Z, or the X? The X. All right, so that means we'll start off with the element symbol, C for carbon. Okay, what does the Z tell us? The atomic number. Okay, it's not given to us in this information, but we can look on the periodic table and find what Z is, because that never changes. What is it? 6. Okay, and now A is the mass number. They're giving it to us here. It says A is 14. So we're done. So now if they asked us to find protons, neutrons, and electrons, we could, right? We know that the atomic number is the protons from the periodic table. Carbon is number 6. The atomic number is Z. Okay? Next. All right, so writing the atomic symbol for this other isotope. All they're telling us is it's an atom and Z equals 11. Okay, so since Z equals 11, what element is this? Sodium. So what is that going to... Since it's sodium, we're going to write sodium for what variable here? X. Okay. Na is your X. Z is given to us, right? So we can put that on the bottom. And now we have to find the mass number. Now here, because they don't give us any information about neutrons or protons, we can look in the periodic table, take the average atomic mass, and round it. So what's the mass number of sodium if we do that? What is it? 23. Okay. So there, we're done with that. And again, now if we had to find protons, neutrons, and electrons, we can do it the way we learned earlier. You look at the average atomic mass on the periodic table, and you round it. So it was like 22.9 something, right? All right, so we're done with that one. One more. Okay, so this one, a little trickier. Okay, it says an atom, Z equals 11, and it has 13 neutrons. Okay, so if Z equals 11, what element is this? Sodium again. Okay, so that we'll put that in for X. Okay, they're giving us Z, so we can put Z here for the bottom. And here, because they're giving us a number of neutrons, because they're giving us the neutrons, we don't have to look at the periodic table and then round the average atomic mass. Okay, using the protons, we can find, using the neutrons they're giving us here, which is 13, we can find the number of protons. Because the number of protons is equal to what? It's equal to the electrons, and it's given to us by the atomic number. Okay, so to find the mass number here, you get the 11. The atomic number is gives you the number of protons. You add it to the number of neutrons. What does that give you? 24. That is your mass number. Okay, if we look at the last example, it was slightly different, right? The last example had a mass number of 23 because we used the average atomic mass and we rounded it. This one, they gave us a different number of neutrons. So that means it's a different isotope. It's like a different version of that same, of an atom of that element. It's one neutron heavier, okay? Yeah. If they give you neutrons, that should be a sign that you don't use the periodic table. Well, you don't use the average atomic mass in the periodic table. You still use the atomic number, though. Okay? All right, so hopefully this helps you figure out your homework. All right.